All right, welcome. We're working on chapter 3, lesson 6. We're going to be talking about ratios and proportions. So, what we're going to learn today in this lesson is we're going to learn how to determine whether two ratios form a proportion, and we're going to learn how to solve proportions. So, some of the vocabulary that we're going to keep in mind are what is a ratio, what is a proportion, what are extremes, what are means, and a rate. So, these are a scale. And so these are the vocabulary terms we want to keep in mind, and we'll kind of define as we go along. So, how are ratios used in recipes? The ingredients in a recipe will make 4 servings of honey frozen yogurt. Carrie can use ratios and equations to find the amount of each ingredient needed to make enough yogurt for her club meeting. So here they show you some ingredients, and ratios and proportions are actually used a lot when cooking or baking. So ratios and proportions. A ratio is a comparison of two numbers by division. The ratio of x to y can be expressed in the following ways. So one way that it can be expressed is just using the word 2 in between, x to y. Sometimes you can use a colon that would also represent a ratio of x to y. X to y, you could use a fraction, right, or division, right? X over y, that would also be a ratio. So here is a way that we're going to look at it. So ratios are often expressed in simplest form. So for example, the recipe above states that there are 4 servings you need, for 4 servings, you need 2 cups of milk. So here, this recipe here makes 4 servings, and it requires 2 cups of milk. The ratio of servings to milk may be written as 4 to 2, right? So this is how we can write it in this form, 4 to 2, right, with a colon. Or it can be written as 4 to 2, right, as a fraction. So these are 3 different ways that we can write a ratio. So that ratio of 4 servings to 2 cups of milk is written in 3 different ways. They all mean the same thing. But written in simplest form, that ratio of servings to milk is actually written as 2 over 1, right? Because I could take this fraction, I can simplify it, right? So it can be written as 2 to 1, 2 with a colon, 2 to 1, or 2 to 1 as a fraction. Right? So let's suppose that we wanted to double this recipe and have 8 servings. So this recipe right here makes 8 servings, but if she needed to make, 4 servings. If she needed to make 8 servings, the amount of milk would require would be 4 cups, right? Because if 4 servings requires 2 cups and she needs to make 8 servings, she would need to use 4 cups. So the ratio of servings of milk is 8 to 4, right? Because in order to make 8 servings, she needs 4 cups. When this ratio is simplified, the ratio is still 2 over 1, right? Because again, 8 over 4 simplifies into 2 over 1. So notice the ratio is equal to the original ratio, right? So the ratio is always the same. It just can fluctuate depending on how many servings we need to make. Because again, no, 4 over 2 equals 2 over 1. And again, just reviewing simplification, right? Both 4 and 2 are divisible by 2. And when I do that, I get 2 over 1. Same thing with the, if I was making 8 servings and using 4 cups of milk, again, both of those are both divisible by 4, which again simplifies the fraction to 2 over 1. So whether I'm using the ratio for 4 servings or the ratio for 8 servings, they give you the exact same thing, which is 2 to 1. So basically for every 2 servings, I'm using 1 cup of milk. So an equation that 2 ratios are equal is what's called a proportion. So each individual fraction here is a ratio. And when 2 ratios are equal to each other, that is what is known as a proportion. So we can state that 4 over 2 equals 8 over 4 is a proportion because both of those fractions are equal to each other. They both equal 2 over 1. So let's determine whether ratios form a proportion. So if we wanted to determine whether the ratio 4/5 and 24 over 30 form a proportion, we would need to find out if they're equal. Well, here I have 4/5, and the easiest way to do that is to simplify it. Well, if I look at 4/5, the biggest number that I can divide into 4 and 5 is 1. So the simplest form of this fraction is 4/5. So 4/5 can't actually be simplified any further because 4 and 5 are both divisible by 1. That's the biggest number they're divisible by. Now, 24 over 30, both of those numbers are divisible by 6. So 24 divided by 6 is 4, and 30 divided by 6 is 5. So if you notice, 4/5 and 24 over 30 both simplify to 4/5. So since they both simplify to the exact same fraction, right, then that means they are both equal, which means since the ratios are equal, they form a proportion. So yes, 4/5 and 24/30 do form a proportion because both of those fractions are equal to each other. All right. Another way to determine whether two ratios form a proportion is to use the cross product. If the cross products are equal, then the ratios form a proportion. So let's try the cross product. So here it says use the cross product to determine whether each pair of ratios form a proportion. So here's a ratio, 0.4 over 0.8, and then another ratio, 0.7 over 1.4. So the cross product, how do you do the cross product? The cross product you're going to do by, some of you may have referred to this as cross multiplying, right? That's what a cross product is. So I take 0.4 and I multiply it with 1.4. Okay, so I'm multiplying across, right, diagonally. And then I'm going to do the same thing with 0.8. I'm going to multiply across diagonally. So 0.8 times 0.7. So I am cross multiplying. I'm doing the cross product. Okay. So again, if I did that, this would give me 0.4 times 1.4. Does it actually equal 0.8 times 0.7? And this is really similar to using the multiplication property of equality, right? Because if I multiplied this side by 0.8 and 0.8, these would cancel out, leaving with just 0.8 on this side. And if I multiply 1.4 here, 1.4 here, these cancel, leaving with 1.4 on this side. So this is the same idea as using the multiplication property of equality, where if you multiply both sides by the same thing, it still makes the equation equal. So are these two things equal? Well, I would put these in my calculator. I find that 0.4 times 1.4 is 0.56, and 0.8 times 0.7 is 0.56. So since both sides are equal, these in fact are equal to each other, right? So since the ratios are equal, they form a proportion. If these two sides were not equal, they wouldn't form a proportion. All right, so let's look at another problem. I have 6 over 8 and 24 over 28. So let's determine if they are, if these two ratios, right, these two fractions are, in fact, do they form a proportion? So does 6/8 equal 24 over 28? Let's use our cross product. So again, I'm going to do 6 times 28, and I'm going to do 8 times 24, right? This represents the cross product. So 6 times 28, does it equal 8 times 24? So I'm going to multiply those out. 6 times 28 is 168. 8 times 24 is 192. Those two are not equal. Since the cross products are not equal, they do not form a proportion. Okay, so this is an example where it didn't work out. So those two ratios or fractions are not equal to each other. So some of the key concepts that we're going to talk about here. So in a proportion, 0.4 and 1.4, right? This is one of the examples we did. Those are known as the extremes, right? So these two here are known as the extremes, and 0.8 times 0.7 are known as the means. And so basically in a proportion, the product of the extremes is equal to the product of the means. Again, it just refers to the cross product that we're doing, right? The cross multiplying. So if I have A over B equals C over D, then A times D should equal B times C. And that's just what's written here, the cross product, right? So here's an example. If I have 2 over 4 and it equals 1/2, then I should be able to do the cross product to be equal, right? So 2 times 2, 4 times 1, and I know 2 times 2 is 4, 4 times 1 is 4, so therefore they are equal. So this is just an example of what a cross product looks like, right? The means extreme property of proportion is just showing you that the cross product actually shows you when they're equal that they're a proportion. So solving proportions. So you can write proportions that involve a variable to solve proportions using cross products and the techniques used over solving equations that we've previously done. So let's solve this problem here. Here I have n over 15 equals 24 over 16. Again, previously we might have just multiplied both sides by 15 and that will also get us the answer, or we can use the cross product. So here's our original equation, right? If I'm going to use the cross product, I'm going to use n times 16. And I'm going to use 15 times 24, right? So there's my cross product. So I'm going to write it out here. So 16 times n is 16n. 15 times 24 is 360. And then just using your normal basics of solving equations, right? I'm going to divide both sides by 16. And when I do that, 16's cancel out, leaves me with n. And then 360 divided by 16 would give me 22.5. So now I was able to solve this proportion and solve for n. So since this says it is a proportion, I know that both of these are equal, which allows me to solve. Look at the next one. The ratio of two measurements having different units of measure is called the rate. For example, a price of $1.99 per dozen eggs, a speed of 55 miles per hour, and a salary of $30,000 per year are all rates. Proportions are often used to solve problems involving rates. So rate, right? $1.99, right? $1.99 for a dozen eggs, right? A speed of 55 miles per 1 hour, and a salary of $30,000 per 1 year, right? These are all rates. You're saying you're getting this many for this many this. This is happening over this amount of time, right? Those are all rates. So let's use rates to help us solve the problem. So this Trent goes on a 30-mile bike ride every Saturday. He rides the distance in 4 hours. At this rate, how far can he ride in 6 hours? So let's go ahead and set up a proportion. So first, let's let m represent the number of miles Trent can ride in 6 hours, right? Because we don't know that. That's our unknown. And then we're going to go ahead and plan, right? We're going to write a proportion for this problem. So here's my proportion. I know that he rides 30 miles for every 4 hours. So he's going to ride m number of miles for every 6 hours, right? These two rates should be equal to each other, right? The ratio should be equal. They should form a proportion, right? So what I want to solve for is m, okay? So again, making sure that I put the right units in the right spot. So 30 miles for every 4 hours, m miles for every 6 hours, right? Hours on bottom, miles on top. And now I'm going to solve this proportion. So again, I could solve it by using the cross product, right? So 30 times 6, 4 times m, right? That's my cross product. And then I'm going to simplify. So 30 times 6 is 180. 4 times m is 4m. Divide both sides by 4. And then I get 180 divided by 4 is 45. 4m divided by 4 is just 1m, right? So now I know that he would have ridden 45 miles, right, in 6 hours. And if I wanted to check to see if this was reasonable, it says if Trent rides 30 miles in 4 hours, that means he rides, if I do 30 divided by 4, that means he's riding 7.5 miles in 1 hour. So in 6 hours, I could say that he could do 6 times 7.5, right? 6 hours times 7.5 miles per 1 hour. And that would equal 45 miles. So the answer has to be correct, right? I can work my way backwards. So since the two rates are equal, they form a proportion. So Trent can ride 45 miles in 6 hours. A ratio or rate called a scale is used when making a model of a drawing of something that is too large or too small to be conveniently drawn on an actual size. So a lot of times you'll see this in maps or blueprints. Those are common things where we use scale drawings. So let's look at this. To use a scale drawing, so here Crater Lake, I don't know if you guys have ever been to Crater Lake. It's a volcanic crater in Oregon that was formed by an explosion 42 times the blast of Mount St. Helens. So the scale of a map for Crater Lake National Park is 2 inches equals 9 miles. So on your map, on the map, every 2 inches on the paper map, would equal 9 miles in real life, right? So the distance between Discovery Point and Phantom Ship Overlook on the map is about 1 3/4 inches. So on the map, the distance is about 1 3/4 inches. So the question is, what is the distance between these two places in real life? How many miles away is it, right? So let's go ahead and do this problem. So we're going to let D represent the actual distance because that's what we don't know yet. That's what we're trying to find. So here I know that I have 2 inches equals 9. So two inches for every 9 miles. And I have 1 3/4 inches on paper. and I'm trying to figure out the actual miles, right? So paper distance, actual distance. So again, I can use my cross product, right? So 2 times d, 9 times 1 3/4. So here's where I'm gonna solve this. So just in case you forgot how to multiply fractions, right? If I have 9 times 1 3/4, the easiest thing to do is to convert it into an improper fraction, right? So 1 times 4 is 4, plus 3 is 7. So 1 3/4 is actually 7/4. And then when I multiply this, I can multiply just by turning 9 over 9 over 1, and then that makes two fractions that I can just multiply across, right? 9 times 7 is 63. 1 times 4 is 4. And then, so multiplying 9 times 1 3/4 is 63/4. So now I have 2d equals 63 over 4. So now I would divide both sides by 2. And again, how do you divide by 2 here? Easiest way to do it is just multiply by half. Dividing by 2 and multiplying by half mean the same thing. So again, I'm multiplying two fractions, multiply straight across, and I get 63 over 4. So, oh, actually, that's 63 over 8. I guess that was a typo there. So ignore that part. So 63 over 8, right? Because 2 times. Oh, yeah, I mistyped it. This should have been 63 over 4. So 4 should have been 4 times 2 is 8. So 63 and 8, or 7 and 7/8, right? Because 63 is divisible by 8 7 times, but you still have 7/8 left over. So 7 and 7/8. All right. So the actual distance on the in real life would have been 7 and 7/8 miles, or on the map it would have only been 1 3/4 inches. All right. Thanks for watching. Let me know if you guys need any help.